right, hello DevFestDC. It's good to see so many smiling faces. Can I get a show of hands if you can hear me in the back? How about now? Yes? Wonderful. All right, so as I mentioned about 15 minutes ago, there is a lot of code in my slides. If you want to grab a copy, there's a link right there to the slides with all the code, as well as a link to plain script, just JavaScript, that is in my slides. I also tweeted that out earlier this morning, if that's a convenient way to grab it. So the variable crimes we commit against JavaScript. JavaScript does some unusual things with variables that if we are not cognizant of, we can accidentally create some pretty tricky to track down bugs. So I'm going to be talking to you today about some of those weird variable things that happen. My name's Julka. I'm a software engineer at Framebridge. Framebridge is a Georgetown startup working on disrupting the custom art framing space. We do both e-commerce and manufacturing. So we have a website where customers can come upload their art, preview it in our frames and with mats. And then we do the manufacturing of the frames as well. So 3 days after we get art in our studio, it is back on a truck with a completely custom cut frame and mat. And to the point as we also source lumber and have it milled for some of our moldings. I work on the e-commerce side on our public website, and with that, I do a lot of JavaScript. So here are some of the things we're going to talk about today. We're going to go over scopes in JavaScript and how they bubble, types of functions, hoisting. We're not actually going to talk about closure today, sorry. Arrays and objects and how they are special in JavaScript from other variables, and then we'll jump into some ES6. So my slides, for the most part, use var when creating variables, and the concepts I am illustrating with the var will lend themselves very well to when we talk about let and const and how those are different from var. All right, so scope. Let's jump right into an example. Silly bit of code. I'm going to set up a variable pink with the value of 1, and then I'm going to take a look at the value in pink. And I'll see 1. I can also console log out window.pink and see the value 1. The window object is our global scope. It is the top level of JavaScript and the variables that are available there. We're working on our global scope right now, so that pink variable that we set up shows up in window as well. Here's that same code with a small change. I now have a var here, and I'll set up fuchsia to have the value of 2. If I take a look at the value in fuchsia, I'll see 2, and window.fuchsia is still 2. In part, this is still doing the same thing because we are working with only one scope. In order to create some short code examples with multiple scopes, I am going to use immediately invoked anonymous functions. And those look like this. We'll set up our function with no parameters that it takes, and then we have the curly brackets, and inside the curly brackets, we'll have whatever code we want to execute. And so this gives us an anonymous function. Then we'll immediately invoke it by putting another set of parentheses at the end. And then to make our browser happy, we'll wrap it in another set of parentheses. All right, and so this pattern is going to show up on a lot of my slides. And here's that first one. So up here, I've got that anonymous function. And at the bottom of it, you can see that extra pair of open and closed parens. So I'm executing it right away. And I'll set up magenta with a value of 3. I'll then take a look at magenta and see 3, and take a look at window.magenta and see 3. I can come out of that function. And if I take a look at magenta, we still have 3, and window.magenta is still 3. So still nothing has changed. In this example, I'm adding in a var here. So we've got var rouge equals 4. And I can use rouge just like I did before, and I'll see the value 4. If I ask for window.rouge, at this point, I get undefined. I can also come out of this function and take a look at window.rouge here and get undefined. And use rouge directly here, but here I'll get a JavaScript error for doing that. So what's happening here is with that var, we are specifying that that variable should only be available to me in that scope. So this var is saying that my variable rouge should only be available inside this function. And it doesn't bubble out into a higher level scope. So here I've got a global scope, my window scope down here, and above here if I had any code. And then inside this function, we're creating a new scope. And in that scope, we've got that rouge variable. And that's why when we come out to the bottom and we try and use rouge outside of that function, we get a JavaScript error. It's also why we're not seeing it as in window.rouge, in the window object, because it's not bubbling up into our global scope. Here's a more complicated example of that same thing. And now I have two immediately invoked anonymous functions nested. So I've got one starting up here, and then a second one. And so in that first one, I'm going to set up var blush to equal 5. Then I can go into the second function and console log out blush, and I'll see 5. I'll change blush to 6, and when I console log out blush, I'll get the value 6. Then I set up a var rouge equals 7, var rose equals 7, and when I take a look at the value in rows, I'll see 7. Now when I come out of that innermost function, down here, I can console log out blush and see that 6 that I set earlier, and with rows, I'll get a JavaScript error. I'm going to continue on as if my JavaScript has not stopped because of that error. And if I come outside of the function, both functions, if I try and use blush, I'll get another JavaScript error, and with rows, I'll get yet another JavaScript error. So what's happening here with rows is we've set rows up in this innermost function with var. So we have a var rows equals 7. So that rows is only going to be available to us inside this function and functions inside of that function, so child scopes. But it is not going to bubble up into the higher level scope. And so I can use rows just fine in here, but when I come out, I'll get that JavaScript error because it's no longer available to me. With blush, I've set up var blush here, so it's available to me throughout this function, but it's not going to be available to me when I come out of it down here. And that's why we get that JavaScript error at the very end. Here's a silly little piece of code, just an if true. I'm going to set up var maroon to equal 29. And if I console log out maroon, I'll get 29. If I come out of this if statement and I take a look at maroon, I'll still get 29. So with var, we are scoping our variable to the parent function or all the way up to the global scope. And if is not a function, so it will come out of that if. And this becomes important when dealing with modern JavaScript frameworks because we are dealing with functions inside of functions, inside of functions, turtles, all the way down. And we might not know exactly how the code we are writing relates to other code in that JavaScript framework and what we might affect. Now, this sort of indicates it as this illustrates it as a waterfall because we have one function with another function inside of it and another function. But this is actually a tree. And each function can have an arbitrary number of other functions in it, and all of those are places where those branches are splitting off into more scopes. All right, so let's try and apply a little bit of that. I've got some code here. I'm going to set up a var amber to be 11, and then go into an immediately invoked function, where I set up var amber to be 12. What do you think we'll get here?
12.
I hear 12, and it is 12. Good job. How about out here? 11, yes, 11. So we've got two separate variables here that are called amber. We've got this first one available in this scope and set up as var amber, and we've got this one available in this inner scope, this child scope, that's also set up as var amber. These are two completely separate variables. They just happen to have the same name, but they're in different scopes. And so when we affect the one inside of this function, it does not affect the one outside of it. I'm not going to talk about those today. So we're not dealing with inside of an object right now, and I'm going to stick with var and let and const today. All right, here's another one. I have a var pumpkin equals 13. Then I set up a function orange and a function tangerine. I'll call orange, so I'll come in here and set pumpkin to 14, and then come out here to tangerine and go in here. What do you expect we'll get out here? 13. We're actually going to get 14. So what's happening here is we have set up pumpkin with var up at the top for this scope. And this is our window scope here, our global scope. When we go into orange, we have a pumpkin equals 14, but we're not setting up a particular pumpkin variable for that scope, which means we are going to bubble up to our parent or our grandparent or our great-grandparent or all the way up to our global scope to find where we might have a pumpkin defined with a var. So in this example, we have not set up a pumpkin with a var here, so we go up a level and we can find one. So we're going to end up using that variable. So we're changing that variable from 13 to 14. And then in Tangerine, we have the same kind of thing happening, where when we go inside of Tangerine, we take a look at this function. It doesn't have its own pumpkin variable set up, so it's going to look at its parent scope to see if we have one, and we do. We have this one. Started off of 13, we changed it to 14, so when we console log out pumpkin here, we'll get 14. All right, another one. We've got a function called ginger and another called paprika. And then we call ginger, we'll set window.peach to 15, and then we'll come down to paprika and go in here. What do you expect we'll get logged out? We'll get console logged out here. Any guesses? 15? That's correct. This is an anti-pattern. Please don't do this. But but it is important to understand what's happening here because you will probably deal with code that does this. So inside Ginger, we are grabbing our global scope, that window object. And if Peach doesn't exist there, we're creating it. And then we're setting the value of Peach to 15. When we go into Paprika, we are using Peach. We're going to see if we have a local variable in that function called Peach. We don't. So we are going to go bubble up to our parent scope and see if that has a variable called Peach. In this example, as soon as we bubble up one level, we are in our global scope. And when we use the window object, we are putting variables in that global scope. So we have Peach available to us that way. Now this can get, yes, go ahead.
You would have rearranged the calls, make paprika call first and ginger second. What would result?
You would have gotten a JavaScript error here because you wouldn't have had that variable set up at all, and the code would have stopped executing. If it hadn't stopped executing, then you'd come into here and then you'd set that Peach. All right, how about this one? I am going to set up a var terracotta at 19, and I have this function blaze, which I then execute. And with blaze, I come in here and I console log out terracotta. What will we get here? I hear 19s, I hear 20s. So this is a trick question, and it is to segue into talking about variable hoisting in JavaScript. So when our browser loads JavaScript, it will take 3 passes over that code. In that first pass, it is going to find any places like this where we do a var terracotta, where we do a var or a let or a const. And it is going to split these lines out into this. So we have a var terracotta where we are setting up that variable as being specific to that scope. And then we have another line that defines terracotta to be 20. It'll then take that var terracotta and move it up to the top of that scope. So it'll move it up to the very top of the parent function. What we're doing at this line is saying we have our own terracotta. We're not going to use our parent's terracotta variable. We're going to have our own. But we're not setting a value in it. So when we come to console log out what we have in terracotta, we'll actually get an undefined here. Now if we went on, here we would get terracotta to have the value 20, and any lines underneath that, inside that function, would be able to use terracotta with the value of 20. And that is variable hoisting in JavaScript. We already had an example that had some variable hoisting going on that moved things a bit out of order. So in this example where we had var rows towards the bottom of a function, what we were actually executing with our JavaScript was something like this. So we have our var rows set up at the very beginning of that function, and then towards the end, we actually put a value in it. Now, we didn't have any unexpected behavior there because we didn't try to use rows before we put a value in it. But essentially, we have the same thing happening there. All right, so here I'm going to call a function called chocolate, and down here, I set up a function called chocolate. So what do you think will happen here when I execute chocolate? That's right. And that is because of function hoisting. You got it right. Most groups don't get it right. My slides weren't ready for that. Yes, so we will get out, yes, please. Good job. And that is because of function hoisting in JavaScript. Specifically, named functions in JavaScript also get hoisted. Now, it's important to know the difference between named and anonymous functions. And this is what they look like. So named functions will look like this. Function, pair, then we define our parameters, we have our curly brackets, and inside we have the code that executes. With anonymous functions, we just say function and then our parameters and our code, and we don't specify a name right here. In this example, I am putting this function that gets created here, this anonymous function, in a variable called pair. And these two pairs would get used in the same way in our code, but they are different. The named function is going to get hoisted, and the anonymous function is not. There are some other instantiation differences to this as well. So what happens with this code where we get yes please is our code is actually going to end up looking something like this. So we talked about that first pass where we pull up those vars. In the second pass of our JavaScript code with our browser, it's going to find named functions. This isn't exactly what happens in your browser, but it does illustrate the order correctly. So for that named function, we'll get a name set up for it in that current scope. So it will be as if we had a var chocolate at the top. Then we'll actually take the definition of the function and set it up after all of those variables have been set up for that scope. So then we'd have something like chocolate equals this function that does this. Now this is especially different from what's actually happening because with named functions, our browser won't go in and evaluate what's inside the function yet. It'll just set it up as some code that needs to get executed for it. And the meaningful difference there is with named functions, we can do recursion, and with anonymous ones, we can't. But this illustrates the idea correctly. And then we'll come to the point where we actually execute chocolate. So we wrote something like this, and what our browser did was flip it and add on a var chocolate at the top. And that is function hoisting. And why you can create named functions at the bottom of your file and use them at any point in it. All right, arrays and objects. So JavaScript is object-oriented. Everything we interact with in JavaScript is an object. So we might have a string, and it has a property such as length, which will tell us how many characters that string has, or we'll have a method on that object like substring, which will grab part of that string out for us and not the entire one. And so all of these things are objects. Now, if we ask for the type of the string yellow, we'll get out string. If we ask for the type of the number 7, we'll get out number. If we ask for the type of true, we'll get out Boolean. And we call these strings and numbers and Booleans, but they're string objects and number objects and Boolean objects. Now, if we ask for the type of an object, in JavaScript, when we set up objects, we do it with curly brackets. So here I am setting up an empty object with no properties. I'll get object. So this is an object. Very helpful naming, I know. If I ask for the type of an array, in JavaScript we set up our arrays with square brackets. So here I'll ask for the type of an empty array, this empty array, and I'll also get back object. So we talk about arrays as if they are array objects. We just call them arrays, but they are in JavaScript objects. Now, if you have a variable that might have an array in it or an object and you want to know what it is, which it is, you can use array.isArray and pass it in as a parameter. So here I'm just passing an empty array, and we'll get a true if it's an array and a false if it's not. All right, who's worked with nan in JavaScript? Yes. So under the right conditions, if you do arithmetic on things that are not numbers, JavaScript will give you a value of nan, not a number. And so just for fun, I threw this in here because this isn't confusing enough yet. Just to entertain myself. So if we ask for type of nan, we ask for type of not a number, we'll get number. All right. So here is a object in JavaScript. I'm going to set up a var canary, and it's going to have two properties. So canary is a bird. I'm going to give the property type, the string bird, and it flies. So I'll say true. Then I have var bumblebee equals canary, But a bumblebee isn't a bird, it's an insect. So I'll change bumblebee.type to insect. What do you think we'll get out here when we look at canary.type? Any guesses? I'm hearing both insect and bird. And the answer is insect. So in JavaScript, when we're working with objects, great naming. When we're working with objects, we are actually working with them by reference instead of by value. So what's happening on this first line is we are setting up this object somewhere, and then we are taking a reference to that object and putting that in canary. And when we say var bumblebee equals canary, we are copying that reference and putting it in bumblebee. We have two separate variables. We have canary and we have bumblebee, but they both have the same reference in them. Bumblebee.type will use the reference in bumblebee to go look up an object and change the type property in it here to insect. And then canary.type does the same thing. It takes that same reference and it looks up that object and it takes a look at the type property. So two separate variables that are pointing at the very same thing. And here is that same thing happening with arrays, since arrays are objects. I can set up a var daffodil with 1, 2, 3. I can set up orchid to equal daffodil. And here we are copying the reference in daffodil into orchid. And if I push on to orchid, the value 4, and I take a look at daffodil, I now have 1, 2, 3, 4, because we are working with two separate variables that point at the same object. All right, let and const, the fun stuff. So in a lot of contexts, we use let in the same way that we would use var. So here I say let green equals 21, and then I can change the value of green to 22. With const, we're specifying to the browser that the value in this variable is not going to change. It's a constant. And so I'll set up const with sage equal to 23. So we have a constant named sage. And when I come in and change the value on sage, I'll get a JavaScript error because I'm trying to change the value in a constant. This behaves interestingly with objects. So here I have a const line, and I'm going to set it up to be an empty array. I'll then push onto lime the value of 25, and then take a look at the values I have in lime, and I'll see that I have this array with a value of 25. Now if I come along further and I say lime now equals this array with the value of 26, that is when I will get a JavaScript error, because that is when I'm actually changing the value I'm storing in lime. So on this first line, we're setting up lime, and we're taking a pointer to this array, and we're putting it in lime. Then we use that pointer to manipulate that array, and we use that pointer to go grab and give us a sort of string representation of that array so we can take a look at it with our console. And that is all right, because we are not actually changing the reference. We're not changing the thing we've stored in lime. What happens on this last line is we are setting up a whole new array over here with one value in it, 26. And then we take a reference to that new array and we try to put it in lime. And that's the point at which we're actually changing lime, which is supposed to be a constant, and JavaScript will stop executing because we have an error, an uncaught error.
So if we did a line.push 26, that would be okay?
Yes. And you could also remove 25 from there and then add 26 so that you get this sort of, that same kind of value if you compare the two arrays.
As long as you're adding them in the same array, not redefined.
That's right. Yes. So that can be very helpful if you want to stop someone from completely reinitializing a variable. Using const also has positive implications in our browsers for performance. So if you aren't going to change that reference, or if you have a string that you know you're not going to change the value of it over time, using a const can give you performance boosts. Here's that same concept with an object. I have const fern, and I'm going to give it one property, name with foo. I'll then come in and use that reference, say in fern, to look up that object, and I'll change the name to bar. I'll then add on the property number onto fern and put in a value of 27. And that is all fine. That does not cause us any problems. Then down here, I am trying to create an object that looks just like the one I have. We've got a name property of bar and a number of 27, which is the same as what we've set up here. And here I get that JavaScript error because again, I'm creating a whole new object here. I'm taking the reference to that new object that happens to have all the same properties and values as this other one, but it is a separate object, and trying to put that reference in fern, at which point I am changing the value in a constant. We looked at some similar code to this with an if true earlier with var, and here's how that works with let. So this is where we see the difference between var and let. So I'll set up a let olive equal 26, and then I'll have this if true. So I'll always end up inside this if, and here I set up a let olive equal 29. When I take a look at the value of olive here, I'll see 29. And when I come out of that if statement, I'll see 28. So with var, what we had happening was the scope of that variable was the parent function, or if we're at our global scope, our global scope. With let, the scope of our variable is going to be the parent code block. And this if statement is a code block. So here, we set up one olive here, and we have a whole nother one here with a new scope. So two separate variables with different values. Yes?
In the first line, instead of let, if you use var, is it going to change or is it?
So in this specific example, if you only change this first one to a var, it would not change because we are at our global scope. And so there's no code, there's no parent scopes to look up to. So if we were deeper inside this, say we were inside of a loop or multiple if statements, and we used var here, and this was all inside yet another if statement, then it would behave differently from var because it would be scoped to just that containing if statement. Versus with var, it would be scoped to that function. Now, your nearest code block with let can be your parent function, in which case it behaves just like var. And now, you might see some applications for this to keeping your code cleaner and not having variables lying around that you're not going to use later on, maybe a bunch of steps you're doing, and you might feel tempted to put some silly if trues in your code, and ES6 gives us a tool for this. We can create arbitrary code blocks with ES6 with just curly brackets. And so this functions the very same way. I set up a let moss with a value of 26, and inside this code block, I set up another let moss with 37. Here I have 37, out here I have 36, and no if true. This becomes especially useful to us in loops. So here I am setting up a for loop with let emerald equal 30. So this is my iterator that I am initializing when we start this loop. Then I have my comparison that decides whether or not I'm going to go through this loop. So I'm going to compare emerald against 34. And if it is smaller than or equal to 34, I will go into my loop. Each time I go through the loop, at the end, I will increment emerald. So it'll go from 30 to 31. And here, when I console log out, the first time we'll console log out 30. We'll increment emeralds to 31. 31 is still smaller than 34. We'll console log out 31, 32, 33, 34. After we console log out 34, emerald will increment again to 35. 35 is not smaller than or equal to 34, so we break out of our loop. And we come down here. And here, if I try to use emerald, I'll get a JavaScript error because it's not available to me here. That let scoped that variable emerald only for inside that for statement. It's not available to me outside. So if you've ever had a situation where you use I and J and K and L and M as your incrementers to make sure that you don't bring a value along with you, let takes care of that for us because that variable is not going to stick around outside of that loop. Here's that same code with a var. So I'm setting up var emerald equals 30, and I'll console log out the same values, 30, 31, 32, 33, 34. With 34, we'll increment it again to 35, and look at our conditional. So 35 is not smaller than or equal to 34, and we break out, and we make it down here. And down here, when I take a look at emerald, I can still get that value of 35. So even though that var is here inside that for loop, it is being scoped to its parent function, or in this case, the global scope, because I'm not inside of a function. And it is still going to be available to me down here. Now, browser support for ES6 is improving every day. Here, for example, is a screenshot from just the other day from caniuse.com for const. And we can see that we have it available to us in IE 11, Edge 16. It looks like, according to them, 97.2% of internet users are using a browser that supports const. And so that's something, depending on what browsers you need to support, you might be able to use right away. And for example, here is the support for JavaScript modules via a script tag, and that is much poorer. It's at 71.93% right now. And if you have to support IE at all, which I think a lot of us do, I have to, unfortunately. I envy those of you who don't. We have an issue. Now, we can work around this with transpiling. The most popular transpiler I know that, and the only one I've used, is Babel. It will take your JavaScript code and you will tell it what browsers you need that to work in. And it will change it around. So it'll take out consts if it needs to. It'll take out those lets and set up the code to run in the same way, but with simpler JavaScript that previous browsers can run. And with transpiling, we can start writing modern JavaScript now and transpile it for the browsers we have to support. And as those browsers change, we can change our configurations for a transpiler to do less of that and use more of the modern features outright. So that's a way to start writing modern JavaScript today. You can transpile down based off of browser. You can transpile down to ES5 or ES3, depending on what you need to support. Right. So we've talked about scopes.
Is it a post-processor like TypeScript? If you have to run it through a transpiler and it spits out a file result?
That's correct, yes. So it rewrites your JavaScript. A lot of ES6 can be implemented with just syntactic. A lot of it is syntactic sugar, just new ways of doing the same thing. Sometimes there are fundamental differences underneath on how the browser works with it, like const. There are memory.
What is the final result? Does it support all the browsers? If you write some code to support all browsers?
Yes, all the browsers you tell it to. So if your browser doesn't support const, it's going to pull all those consts out and change them into something else.
And is there what, a configuration file where you tell it what browsers you want to hear about?
Yes. You tell it what you want to target, whether it's specific browsers or ES5 or ES3 in general.
Is that the main purpose of Babel? Or is that not really Babel's purpose? The transpiler without Babel?
Babel is a transpiler. I don't know off the top of my head if it does more than just that.
So Babel is the most popular transpiler?
Yes, I would say that. All right, so we've talked about scopes in JavaScript and how they bubble up from all the way up to the top level scope if we don't use var, let, or const. We've gone over the types of functions we have in JavaScript, named and anonymous, and how named functions hoist differently. We've gone over hoisting, both for those named functions and for variables. Gone over the ways arrays and objects are extra special. Love our objects. And we've gone into ES6's let and const. I did want to leave you with a couple more resources. If you are not using it already, I strongly recommend MDM, Mozilla's developer network. It has great documentation on how you use different aspects of JavaScript and different methods on our objects or different functions, as well as telling you the support of those in different browsers. And caniuse.com. I use some screenshots from their documentation on ES6, but it'll let you know what browsers support it at what versions and how much of the internet that covers. Thank you very much for joining me today.